My name is Liheng. Today I'm presenting the study by Somerville et al. As a part of the synopsis presentation. Adolescence is a phase of human life course defined by the immense social neurological changes. A unique feature of adolescent behavior is the heightened concern over perceived instance of peer evaluation, due to the fact that adolescents spend more time with peers relative to children and adults. Consequent influences are rising concerns over social evaluation, peaking self-consciousness, and being the target of social evaluation. Neurodevelopmental research suggests that brain development are consequential to unique aspects of behavior that emerge over the life course. Neurological evidence has shown that the medial prefrontal cortex, MPFC, is involved in social and emotional processes and adolescent self-concept. Despite above information, little is known about the biological mechanisms that accompany the phenomenological shifts in adolescent social concern. Therefore, this study sought to test the hypothesis that experiential, autonomic, and social affective brain responses would change non-linearly from pre-adolescence to post-adolescence, even under minimum condition simply being looked at. So specifically, we'll be examining whether adolescents experience heightened emotional and autonomic responses to instances or perceived instances of peer evaluation, and also whether the MPFC is recruited under such situation, and whether such potential effects persist into adulthood. We recruited 69 human participants ranging from 8 to 22 years old who completed self-report, galvanic skin response GSR, and fMRI measures, and participants were led to believe that a small one-way video camera was embedded in the head coil of the fMRI scanner, and all participants were instructed to passively view the screen and monitor the changes, and the detail can be seen in Figure 1. There are 3 modes in the screen, and participants were instructed that a same-sex pair of similar age would monitor the video feed during the scan when the screen says system on. And also, 3 aspects are measured in the experiment. Immediately following the task, participants were asked to rate the extent to which they experienced the following emotions: happiness, excitement, nervousness, worry, fear, and embarrassment. Participants rate each emotion category by bisecting a continuum line with far left anchors not at all and far right extremely. We use 3 continuous age predictors shown in Figure 2, the linear age predictor to the left, and adolescent-specific predictor in the middle, and the adolescent emergent predictor to the right. We believe that it will provide the most effective and unbiased method of identifying age predictors that explain the variance in the variables of interest. For emotion, affect analysis indicated 3 latent variables: anxiety, positive arousal, and embarrassment. A group ANOVA is used to test effects of task phase and age predictors on self-reported emotions as shown in Figure 3. There are 56 usable participants in skin conductance analysis. Analysis for block design data is used to address the habituation issue. Group analysis is used to test the effects of task phase and age on GSR, which is shown in Figure 4. Functional imaging data was pre-processed with analysis software, and here we will focus on age effects that persist for both anticipation and evaluation conditions, as observed for embarrassment and GSR findings. As shown in Table 1, we found the adolescent emergent age predictor yielded a significant main effect on the embarrassment rating. At the same time, the adolescent-specific age predictor yielded a trained-level prediction of embarrassment rating. Results provided consistencies in age effects on embarrassment in both conditions, but a more robust age difference during the evaluation phase. Skin conductance data yielded a quadratic age-by-time interaction, which indicates that even minimum social evaluation are sufficient to induce heightened self-conscious emotion and physiological arousal. An estimated age of peak SGSR response was 14.38 years. Guided by the behavior findings, as we will be seeing from Figure 5 and 6, the MPFC demonstrated an elevated response in adolescents both during anticipation and evaluation condition that partially retained its activity strengths into the young adulthood. We also found that MPFC coupling with the dorsal striatum that significantly fits an asymptotic age pattern. No other activations were observed for this analysis. No regions demonstrated significant linear age or adolescent-specific effects at whole brain corrected thresholding. The estimated age peak in MPFC activity was 15.25 years. Here now we can see that our findings supported our hypothesis. We also noticed the self-consciousness increased during adolescence and alleviated into adulthood. Arousal level peaked during adolescence. We observed a few factors that would contribute to social evaluations in adolescents' everyday life, which are increased rate and intensity of peer interaction, which is associated with amplified motivation for peer acceptance, and the non-linear change in MPFC activity is connected with the behavioral emotional shifts in adolescents' social sensitivity. We also suggest that the mechanisms that modulate adolescents' motivated behavior lies in the steady MPFC signaling and enhanced MPFC striatal regions connectivity. The MPFC is not exclusively social. The non-linear age differences we observed in anticipation situation indicate that the MPFC activity in the present study serves to incorporate salient contextual cues with emotional value processes. This conceptualization is consistent with prior findings, indicating that MPFC response to positive and negative social feedback is exaggerated in individuals with particularly salient social feedback, such as individuals with low self-esteem. The other point we want to mention is the interpretation of some of the data, and there are subtle differences between the peak ages for GSR, MPFC activities, and self-reported embarrassment. Each measure contains its own profile of measurement errors, so direct quantitative comparison is not encouraged. The present study offers supporting evidence for MPFC's significant roles in social cognition, emotional evaluation processes, sustaining a presentation of peer evaluation, as well as modifying a goal-directed behavior. Our study also endorses the existence model of peer influences on adolescents' decision-making. Despite above strengths, we have some limitations as well. This study lacks self-examination of other factors such as genetic, personality, etc. And we also can't completely eliminate the self-report bias. More importantly, our study echoes the limitation of a typical cross-sectional study. That is, we used different people in the cohort, so we have more variables, and longitudinal study was usually more effective in such case. However, a longitudinal study can be very costly and also generate great habituation issue when testing skin conductance. Last but not least, our study does contribute to the discipline with a few implications. It sheds light on how behavioral, emotional, and social influences interact, as well as how salient characteristics of adult social context cast a substantial impact over motivation, emotion, and well-being. Future studies are warranted to assess whether the variance of age pattern into early adulthood is replicable with a broader range of age. More studies are desired to assess whether the particular convergence of measure during adolescence plays a functionally and significant role in promoting social sensitivity. Moreover, future work will be needed to identify the biological and experiential mechanisms that give rise to the function differences illuminated by the present study. Together with all the implications and strengths, the long-term goal for this study is to establish a greater understanding of adolescence as a distinctive developmental stage.